Okay, Science 10, let's explain this graphic. So the two key concepts for chemical reactions, reactants on the left, they must be in balance with the products on the right. And this mass, of course, or the number of atoms can never be created nor destroyed. Mass just changes form. That's the law of conservation of mass. Mass is conserved. Whatever mass is on the reactant side has to equal and be the same as the mass on the product side. Of course, it's changed form. This is hydrogen gas and oxygen gas becoming water, but it's still hydrogen atoms and oxygen atoms. And notice that the number of atoms on the left side here equals the number of atoms on the right side here. This reaction is incredibly violent and releases an immense amount of energy. Now, of course, if we just had 2 molecules of hydrogen gas and 1 molecule of oxygen, that would be really small. But what we actually have here, what's written and how to read this says 2 moles of hydrogen gas, which if we add it up, adds up to about 4 grams. And we're going to see where I got that number from, but just know that for now. Plus 1 mole of oxygen gas, which adds up to about 32. So 4 grams plus 32 gives you your 36. We'll see the exact number in a moment. This reaction then gives you 2 moles of water. 1 mole of water is about 18 grams. 2 moles is 36. So let's look at this. Grab your periodic table. Make sure you have a calculator as well. Same reaction, now just written using the periodic table. Take a look carefully. If we have 1H2, this would be 1H2. Of course, it says we have 2 hydrogen and 2 moles of hydrogen. Add up this molar mass right here, 1.01, multiply it by 4, you get about 4 grams, 4.01 to be exact. And if we've got 2 oxygens, 16 plus 16, or 16 times 2, that's going to be 32. Check out the water now. So if you've got, again, 1 gram there, 1 gram there, 16, so that's about 18, right? 1 plus 16, that's about 18. That's going to be your 36 grams as well. 36.04. Take your calculator. This is exactly what this adds up to. And this proves that mass is conserved. The mass is never lost. Sure, the reactants change into new products, but it's still all the same atoms. Count them all up. The same number of hydrogen on this side is on the right side. The number of oxygen you see here is the same as the number of oxygen as long as you balanced it correctly. All right, let's take a look at this one other way. So again, same reaction, has to be balanced correctly, but this is saying 2 H2s, so in other words, 2 times 2, in other words, 4 hydrogens, 4 times 1.0, that's going to be 4.04 grams. O2 means 2 oxygens, so 2 times 16 grams per 1 mole, so that's 32. Take your calculator. 4.04 plus 32 is going to give you 36.04. But let's check this side. Let's check 1 mole of water. 1 mole of water is going to be 1.01 plus 1.01 plus 16. That's going to be 18.02. Check it one more time though. Clear your calculator off. 1.01 plus 1.01 plus 16. Again, 18.02. Take 18.02, just multiply it by 2. In other words, 2 water molecules or 2 moles of water, 36.04. You'll see that these two match. Okay, Science 10, wanted to explain this graphic. It's critical that you know how to balance chemical reactions, and it's critical that you know that mass is conserved. Mass never is destroyed or created, it just changes form, and you have to respect that, and you have to balance chemical reactions. Take care.